The lesson topic for this video is interpreting graphs. So, obviously from the title, we are going to work on looking at a graph and interpreting information from it. So, just going to look at a list of questions here based on this graph. So, anytime you're going to do this kind of thing, always first just take a look at the graph, look at the headings, look at the line, look at the scale on the graph, on the X and Y axis. Take it all in before you try to answer the question. So if we look at this, we see on the X axis here, time in weeks is going along the X axis, and then on the Y axis we have beard length. So this is some information or data on how long people's beards are after a certain number of weeks. All right, so that's what this is all about. As you can see on the Y-axis, we go from 0 to 60 and further in millimeters for the length of the beard. And then we have, obviously, the linear situation here as time goes on, the beard length grows, of course, unless somebody were to shave it. All right, so question number 1, what does the point 1035 represent? All right, so if we look at the point 1035, 10 is our X value and 35 is our Y value, so 10, 35, and 35 is right here. So where did 10 and 35 meet? That's a point right here. Well, what that represents is that after 10 weeks, the beard is now 35 millimeters, right? So I'm going to go ahead and type this in. After 10 weeks, the beard is 35 millimeters. Okay. All right. Now remember, when you answer these questions, you do need to be specific about the data. You need to talk about time in weeks and beard length in millimeters. So be specific to the situation. Second question, what is the slope of the line? Well, we've talked a little bit about slope when we've been graphing lines, and slope, of course, is rise over run. So if you need to find the slope of this line right here, we need to find 2 points, and then we can count the rise and the run between those 2 points. Now, it doesn't matter which points you choose, but I always say find handy points. Like that 1035 is handy because it's right where the two whole numbers 10 and 35 meet. I would probably not choose 5 for weeks, because 5 for weeks kind of comes in here in the middle, and then you'd have to do a little bit more estimating. Not that that's a bad plan, but we could try to find a better point. I think a better point would be over here at 20, 60, which is right here. It goes right through hole number 20 and 60. So then we count our rise and our run. So be careful when you do this, because what you don't want to do is say 1, 2, 3, 4, 5 if the scales are different. Because then you'd say 5 over 1, 2, 3, 4, 5 over 4. What you find out is that this is not going to be 5 over 4 for the slope, because as we go up here, we're going by each square represents, in this situation, 5 units. So we're going up 5, 10, 15, 20, 25. So 25 is our rise, and then our run from this point over to here is, and these go by 5 for 2 sets of boxes or squares on the grid. So 5, 10, right? From here to here is 10. So you have to be careful with that. Rewatch if you're not sure what I'm talking about there, but we are going from, we are going from 10 on the x-axis to 20 on the x-axis. 10 to 20 is 10 units. And going from here, which is at 35, to here, 60, is 25 units. So we're rising 25 and running 10. So 25 over 10 is our slope, and of course we can simplify that. If we divide top and bottom by 5, we get 5 over 2. So our slope is 5 over 2. All right, so next, what is the x-intercept? Well, we do know that our x-axis is right here, and on this, for this line right here, we cannot see the x-intercept. It would be over here somewhere. So what does that mean? In the situation for this graph, what it means is that it was several weeks ago that the beard length was what? 0, right? That's what the x-intercept means in this situation, is what the beard length was, when the beard length was 0, right? When the beard length was 0. It might help to kind of extend our x and y axis, if that helps, and to think about how it would have dotted down like this until we get to that x-intercept right here. That's where it would be if we continued the line. So again, what does that point mean? Well, that x-intercept means at what time was the beard at 0. Okay, so that's the kind of thing we're talking about in this situation. So the number of weeks ago that the beard length was 0. Okay. Next, what is the y-intercept? Well, you'll see the y-intercept right here. It's where it crosses the y-axis, and that y-intercept is 10. Right? And what is its meaning in the context of the graph? Well, the meaning of that 10 in context, and again, in context we need to use these labels. The meaning of that point, the y-intercept of 10, is that when there were 0 weeks, the beard was 10 millimeters long. Another way of saying this is 10 millimeters is the original length of the beard. That was the length of the beard when they started keeping track. So like the original amount. And that's often what our y-intercept will represent, is the beginning or original amount. All right, so in this example, again, I would suggest that you go ahead and take a look at the graph before you even read these questions here. This graph says bike weight versus jump height. All right, we've got on our x-axis, we have 16 through 25. Our y-axis goes from 9.0 here to 10.8. Down here, this is the weight of the bike in pounds, so how much the bike weighs. And then on the vertical axis, the y-axis, is how high can you jump with that bike based on its weight. Okay? So, first question says, if Jose's bike weighs 21 pounds, what would be his maximum jump height? All right, so weighs 21 pounds is right here. What would be his maximum jump height would be 10 inches. So we can go ahead and write 10 inches there. Second question, if Sonia can jump a max of 10.4 inches off the ground, what does her bike likely weigh? All right, so 10.4, here's 10.4 jump height. How much does her bike likely weigh is right here, and that is right in between 18 and 19, so 18.5 pounds. And LBS there, of course, is pounds. All right, the next question. Let's be careful with this one. It says, do you know the x or y intercept? If so, what do they represent? Now be careful, because you might think that this is the y-intercept, but it isn't. Because a y-intercept is the y value when x is 0. Well, on our x-axis, we don't have x is 0 on here. We have x is 16. So this is not a y-intercept here, and we can't see the x-intercept over that way. And even if we could, again, it wouldn't be the x-intercept, because we'd have to go down to 0 for y. So no, we do not know the x or y-intercept in this situation. And if we think about it some more, think about, okay, so if the weight was 0 pounds, well, no bike weighs 0 pounds, so that wouldn't even exist. Could the jump height be 0? Yes, it could, if you have a very, very heavy bike. And I don't know when that would be, that you would have no height ability, but that's where that would be represented. All right, on to question number 4. Explain what the point 23.5, 9.6 means in the context of this graph. All right, so let's go ahead and find that. 23.5 as our x value, and that's right in here, right? 23.5, and 9.6. 9.6 is right here. So where do those two meet? They meet right here. Right? So what does that represent? Well, it would be when a bike weighs 23.5 pounds, the predicted maximum jump height would be 9.6 inches off the ground. And again, just to reiterate, when you're asked to explain what a point means in the context of the graph, you want a full sentence and you want to make sure to include both types of labeling in your response. So when the bike weighs this many pounds, the predicted maximum jump height is this many inches.